Okay, in this video, we're going to be looking at mass to mole conversions in stoichiometry using the BCA table. So far, we've looked at how we can use the BCA table to help us to be able to keep track of all the different moles of the different substances in a reaction. And now we're going to factor in calculating with masses as well. So going through three particular examples. So the first one, we have using the Hoffman voltameter, a chemist decomposes 36 grams of water into its gaseous elements, which would be hydrogen and oxygen. How many grams of hydrogen gas should they get, which is what we call the theoretical yield. So the first thing that we have to start with is we have to start with an equation. So we have 2 molecules of water decomposing into 2 molecules of hydrogen and 1 molecule of oxygen gas. Now we're going to use the information that we're given in the question to start to calculate the number of moles, because remember, with the BCA table, it only works with moles. So we're told we have 36 grams of water. We can multiply by the molar mass of water as a factor to work out we've got 1.99 moles of water. And that would go in our before section of our table. Now we know that we should have 0 moles of both products because we haven't made anything yet. We know that the water is all decreasing. So we're using all of the water up, so that we end up with 0 moles of water at the end, and we can use our mole ratios to identify that I should produce the same number of moles of hydrogen gas as the amount that water got used up, but also that the oxygen will be half that amount because I have a 2-to-1 ratio. So, yeah. So now what I can do is, with this information that I should produce 1.99 moles of hydrogen gas, that I can multiply by its molar mass, which is 2 times 1.008 grams for every 1 mole, and get 4.03 grams. Now I've done all the hard work. I have my BCA table, I have my working out space, but I need to sum it up in the end. So I need to make the statement at the end to address the question. Therefore, 4.03 grams of hydrogen gas will form. Moving on to the next example, which would be question 4 on this sheet. Suppose 4.61 grams of zinc was allowed to react with hydrochloric acid to produce zinc chloride and hydrogen gas. How much zinc chloride should form? And if 8.56 grams of zinc chloride was actually recovered, what is the percentage yield? So again, we start with a balanced chemical equation. Okay, based on the information given to us, we can work out that the moles of zinc is 0.070 moles. Now notice that I've put the ... in there to represent that there are more decimal places in my calculator than I'm actually expressing when I write it down. So I need to make sure that that's the value that I can continue to calculate with, but I don't have to write every decimal place in my BCA table. Okay, so you can use that ... to represent that concept. Okay, so I start with that information I can put in. I'm assuming that I have excess hydrochloric acid, and I know that I will have 0 moles of both my products because my reaction hasn't started yet. Okay, so now I've started to use this information to do some further calculations. I'm assuming all my zinc is being used up, so I have 0 moles of zinc in the end. And now I can start to use my mole ratio to work out how much of my hydrochloric acid decreases and how much my products increase. So because I have a 2-to-1 ratio of zinc to hydrochloric acid, I know that I will be using up twice as much HCl, so 0.14 moles. But because I had excess to start with, I will still have some unknown amount left over. Okay? Because of the nature of the question, that's not concerning me too much at this point. Okay? But I can see from my equation that I have 1 mole of zinc chloride for every 1 mole of zinc that reacted. So therefore, the moles of zinc that reacted to start with is the same as the moles of zinc that will form. And because I have a 1-to-1 ratio with hydrogen as well, both of those numbers will be the same. Okay, so now what I need to do is I need to convert that to a mass to address my question, working out the mass of zinc chloride. So I take that mole value, the exact value that's still in my calculator, and multiply by the molar mass of zinc chloride. Now take note that zinc chloride is ZnCl2. So I need to make sure I include 2 chlorines in my molar mass. So I get a mass of 9.61 grams of zinc chloride. Okay, so that addresses the first aspect of the question. But then I'm asked, if 8.56 grams of zinc chloride was actually recovered, what is the percentage yield? And so to calculate the percentage yield, I'm doing 8.56 grams divided by that theoretical yield of 9.61 times 100 to get 89.1 to 3 significant figures. So then, as before, I need to make a summing up statement. 9.61 grams of zinc chloride should form. My percentage yield is 89.1%. And now moving on to the next example, looking at question 6 on the sheet. In the reaction between excess potassium solid, that is potassium metal, and 4.28 grams of oxygen, O2, potassium oxide is formed. What mass would you expect to form, that is the theoretical yield, and if 17.36 grams of potassium oxide is actually produced, what is the percent yield? Okay, so same deal as before. Start with a balanced equation. Okay, so 4K plus O2 goes to 2K2O. Based on the information given to me in the question of 4.28 grams of oxygen gas, which is O2, I can work out how many moles that I have. Note that I have the 2 times 16 in my molar mass down here to reflect that this is O2. Okay, there's a trap there, so make sure that you're aware of that. So I have 0.133 moles of oxygen as my before line. I know that I have excess of my potassium metal, and I should therefore also have 0 moles of my product. So now I'm assuming that all of my oxygen will react, so minus 0.133 to end up with 0. Okay, now I can work out how many moles of potassium oxide will form based on my mole ratio of 2 to 1. So I'm use the mole this as a factor to multiply to work out I get 0.266 moles of potassium oxide. So I can fill in that section of my table. I can also use the information of a 1 to 4 mole ratio between my oxygen and my potassium to work out that I should decrease by 0.535 moles. However, because I started with excess, I still have an unknown difference there that doesn't matter to me at the moment, but I now need to go on and continue to answer the question. So I have the moles of potassium oxide, I need to convert that into a mass. So 0.266 moles multiplied by the molar mass of potassium oxide, taking it as before, taking note of the fact that I need 2 lots of potassium, so I get 25.05 grams as my theoretical yield. If 17.36 grams of potassium oxide is what's actually produced, I divide that by the theoretical yield times 100 and then make my summing up statement at the end. 25.05 grams of potassium oxide should form, and my percentage yield is 69.3%. So there we go, talking through how we can actually use a BCA table to make mass to mole conversions to further our understanding of stoichiometry. Thanks for watching.